Triangle side ratios. This is another important thing to learn when it comes to trigonometry. So we're going to cover two types of right triangles, and we're going to cover the ratios between its sides. But in this video, we're going to cover just one because it takes a bit of explaining. So the two types of triangles you're actually going to learn about is a 45, 45, 90 and a 30, 60, 90 triangle. So what a 45, 45, 90 triangle would look like, it's a right triangle that's like it's like a square cut in half, right? And you have two 45-degree angles, right? 45 degrees, we put a degree symbol here. And then obviously we know this is 90 degrees because these add up to 90, and this must be 90 because 90 minus 180 is 90. And this is just a right angle anyway because it's a right triangle. But this is a 45, 45, 90 triangle where there's two 45-degree angles and a 90-degree angle. A 30, 60, 90 is a bit different, and you might have remembered these. I definitely drew these in the previous video. It just wasn't a 30, 60, 90. I used different angles. But this, what a 30, 60, 90 triangle looks like. So this looks about like 60 degrees. This must be 30 degrees based on that. And obviously we know that's 90 degrees. This is a 30, 60, 90 where there's a 30, a 60, and a 90-degree angle in this triangle. And that's what the two triangles are. Today we're just going to focus on the 45, 45, 90 triangle just because it's going to take a bit of explaining like I mentioned earlier. And I'm going to kind of go over the side ratios here, and then I'm going to go over why it's that. So if we look at, let's get a brand new 45, 45, 90 triangle here. So let's say this is our 45, 45, 90. So we know that this angle and this angle are the same. That's 45 and whatnot. And let's say this is side X. Alright, so according to the rules on the 45, 45, 90 triangle, the two legs are the same distance, and the hypotenuse has that distance times the square root of 2, a root 2 distance. So if you were to make this into a ratio, you would say a 1, 1, root 2 difference here. This is our ratio between the sides, all three sides. So this is a leg, that's a leg, and this is the hypotenuse. So based off of that information, we can say that if this leg is x, then that this leg must also be x. And then we know that if this is the hypotenuse, because we said these are the two legs, and these are the same, it's going to be whatever the leg is times the square root of 2. And that is the ratio here. So like I mentioned earlier, the ratio, let me make it a bit neater. The ratio is a 1 to 1 to root 2 ratio. This is the ratio right here between all three sides. The first two are legs and the last one's the hypotenuse. So now, why is it that we have this root 2 here? So picture this. We have a square, a perfect square, right? It's not a rectangle, it's a square, right? And this side is we'll say 1 centimeter. And this side is 1 centimeter. Well, we know that the area of this is equal to 1 square centimeter, right? Well, now here's the thing. Now, let's say for whatever reason, you want to cut this square down the middle with a triangle line. And now you made two right triangles. Well, let's draw another little right triangle out here. And we're just going to say we're pulling this triangle out here. So now we know this side is 1 centimeter, and we know now this side is 1 centimeter. But this right here is the hypotenuse. So this, in reference to that image, that would be the hypotenuse, right? Well, here's the thing. If you were to use the Pythagorean theorem, which remember the Pythagorean theorem is a squared plus b squared is equal to c squared. That's the Pythagorean theorem. If you were to use the Pythagorean theorem on this, you would get 1 squared plus 1 squared is equal to c squared. In another way of writing this, if you were to just solve for c, you could say c is equal to the square root of 1 squared plus 1 squared, right? Which this is just saying c is equal to the square root of 2, right? Now in this case, you could say that this is 1 times the square root of 2, but that doesn't necessarily make sense. I mean, yes, it's true and it makes sense because, 1 times square root of 2. But 9 times out of 10, when you see somebody drawing or writing this out, you're more than likely to just see root 2, because 1 times root 2 is just root 2. I mean the same thing. So that's why it's root 2. And that is a 45, 45, 90 triangle side ratios.